All right, let's get started. So, more people. Thank you everyone for being here. This is the last session before, we have to go back to the main hall. But this is a really interesting one, in my opinion. So we'll have Gophers continuing up the Iceberg. That Matt, who's a staff software engineer from Voltron Data, and we'll have a Q&A section afterwards. Take it away.
Thank you. All right, so as Kevin just said, I'm Matt. I work at Voltron Data, and my primary thing is I'm an open source engineer. My primary work is I work on Apache Arrow, Iceberg, ADBC, various other open source projects and setups there, and that's just what I do. I also wrote the book In-Memory Analytics with Apache Arrow. I ran out of my copies at the little book signing thing, so don't have any copies to give out to you guys, sorry. But I had the second edition, came out last October, and you can easily find me all over the place on LinkedIn and so on. I'm a PMC member for Arrow, and I am a committer on Iceberg. So let's just kind of dive right in here. I'm going to assume that you guys know enough of the Iceberg metadata stuff from the keynotes that I don't need to explain how that works. But so a while back, originally, obviously, there was only the Java implementation for Iceberg. And so there was a big ask from the communities for non-JVM Iceberg implementations. And thus we have PyIceberg and Iceberg REST. And of course, as I started Iceberg, I created Iceberg Go and worked with the community to kind of work on that and get it as part of the official repos and so on. There is obviously the canonical Java Scala one. You've got PyIceberg, you've got Rust, Go. There is a C++ one, and so on as moving along. And yeah, it's the JVM that's wrong, So in case anyone is not, as well versed or not, or, maybe just curious why I decided to do a Go implementation for Iceberg. I'm a big fan of the Go language. Just straight up, I'm a big fan of Go. It is extremely portable. It is extremely easy to distribute binaries that you compile for Go because of the default static linking. It's essentially the kind of the language of the cloud is what it's become. If you're writing services, if you're dealing with Kubernetes and Helm charts and all that stuff, you're probably dealing with Go or want to, or you should be if you're not. And it compiles down to native code. It's not running on a virtual machine. It is garbage collected. The garbage collector is pretty good. And it has a lot of interoperability with other languages and FFI as necessary. And just generally, it also makes writing concurrent code significantly easier than pretty much any other language I've dealt with. And that's really important when you're dealing with something as finicky and as important as data formats and data systems, especially when you're trying to implement Iceberg. And when you parallelize stuff, makes it for just easier to read, easier to parse out code. So some of the use cases of just non-JVM Iceberg implementations, you want distributable CLIs. You want to avoid the startup cost of a JVM when you're running a command line utility. If you want to deal with integrating Iceberg with non-Java languages, you don't want to deal with all the overhead and baggage that comes with JNI and other, situations. You don't want to deal with Spark. There's plenty of reasons why you want a non-JVM Iceberg implementation. So, the current status, where we currently are with Go Iceberg implementation, we recently pushed out version 0.2.0, which finally added some write support. Yay! Write support. It added the fast append path, so it can write you can add a file directly. Not released yet, but what recently merged is being able to actually write streams of data. And as one might expect, given my intro, it's all utilizing Apache Arrow as the data format for how you get data in and how you get data out. You're getting streams of Apache Arrow record batches and dealing with tables at that part, so everything stays column-oriented. It currently supports S3, GCS, local file systems, recently added Azure support. We also support the catalog implementations, REST catalog, SQL catalog, Glue catalog. There's a group from AWS that contacted me that are looking at trying to get the close the gap of the Glue implementation with the other catalogs, which is awesome, and I'm very happy to work with them for that. It has full read support in most cases. We don't support equality deletes yet, but it does support position deletes. You can get all of your data out as an asynchronous stream of data. It'll handle the push, it'll handle the filtering expressions and all the standard stuff that Iceberg supports, and is all backed by Apache Arrow compute and optimized assembly and so on. Currently, it only supports Parquet files. Doesn't support Avro or ORC or Puffin data files yet. I don't know why you would want Avro or ORC in this case. Well, ORC maybe, but yeah. And so the write support is able to create new snapshots, as I said, because you can add files and you can add new data. We don't have much in terms of the snapshot expiring yet, and some of the other metadata stuff. Metadata management is not there yet, but we're trying. And that kind of like that's kind of like where the current state of Iceberg Go is. So of course, a roadmap. My personal goal is I want to get at least to have feature parity with PyIceberg. And I've had a ton of assistance and help from Faco and Kevin and others in the community of getting there and moving forward with it. Eventually, we want to add support for Hive just because, well, it'll help for migrations. And of course, more of the write support. Equality deletes, writing position deletes, Puffin files, handling compaction, upserts, all the really nice stuff that you want to do with Iceberg. So, pretty straightforward, simple. Yeah, right, simple. So, just some quick examples. There's also a small CLI with the Iceberg Go that kind of mimics the PyIceberg CLI, only it's a statically compiled binary that is distributable as opposed to a Python script. And it has I tried as much to keep similar or the same argument style that the PyIceberg CLI uses for ease of use and ease of interactions. So you can see the example there. You can see it, just connecting to a REST catalog using the Iceberg REST catalog interactions, and pulling out the schema, file list, and so on as you need. And so, what does it actually look like when you're writing the code? That's the nice piece here. What does it actually look like when you're writing code to hit and to utilize the Iceberg Go library? Well, it's pretty straightforward. If you're using the local file system, you can just instantiate, the local FS instance there to use to tell it, and just point it at your location of the metadata.json and load the file, and it creates a table object, which then has all of the metadata from the metadata.json, and you can do your scans, you can do your metadata interactions, and so on. But of course, you want to have a catalog to do more important stuff. So with the REST catalog, I can launch a local min.io instance. You can point it at S3 if you like, however you want, and you can just load the catalog up. You can see on the top there, we import the REST with the underscore because we don't actually need any of the things there. But when you import the REST package, it registers the catalog implementation. Because there may be other catalogs, you may want to do custom stuff with your catalog situations, we have a registry. And when you register the catalog in the catalog registry, then it's available via the catalog.load function, which will go through the registry based on the type argument, the type property, and use that to instantiate your catalog. And so, pass the necessary information with our local min.io, load the table, print out what the location says, so on. You can do scans, and so, etc. So, here's where I tempt the demo gods. So I'm just going to put that right there. Okay. So, let's go over here. No, bad. No. Here. Okay, so some nice simple things. We can instantiate SQL-based catalog. Iceberg and the Java Iceberg both support using a SQL-backed catalog. So, of course, we're going to do the same. In this case, I'm using SQLite. But it also supports Postgres, Oracle, MySQL are all supported. You just have to use the URI accordingly. It also integrates well with Go's driver/SQL package. If you import the SQL package directly for the catalogs, you can create a new catalog by just passing it a pointer to a SQL.db object. As long as it supports one of the dialects, either Oracle, Postgres, SQLite, MySQL, SQL dialects, then it will work. And so you can see here, we have our little warehouse. We got our catalog. I'm going to read one. I have already downloaded one of the taxi trip data, the classic taxi data set. So I downloaded one of the Parquet files. I'm going to read the file in here so I can print out how many rows, just so we can confirm that when I create the namespace and the table and add the file, that after I do my scan, it has all the rows. So we're going to go over here. Come on. Where's my mouse? There it is. Okay, so did I clear out the previous one? Let's find out. I did not. Let me clear out my testing of the demo gods. Okay. So, let's run it. Okay, so we're going to run it. We're going to create our SQL catalog. We're going to do it. And hey, it says it inserted all the rows. That's a good sign so far. How about we double check with Iceberg. So I'm going to load the catalog. So you can see I'm doing the same thing here. Well, I need my warehouse path, don't I? So you can see we're doing the same thing here in Iceberg. I'm going to load the catalog, tell it it's a SQL catalog, give it the same location. Okay, so far so good. It accepted the catalog. It's happy with that. So now we're going to load the table. Okay, so Iceberg read the table. Well, the schema looks correct, right? Okay, so I created my table using Iceberg Go. I added the file, wrote the file to it, and Iceberg was able to read it. So far, so good, right? Cool. Now, what about dealing with our RESTful stuff? Well, nice, simple. Now, part of the CI that we have set up for Iceberg Go involves launching a bunch of Docker images and using Spark to generate a bunch of tables. So one of those tables is this test all types table. And so we can load the table. You can see here, connect to the REST API, just running it locally with the Iceberg REST image. Load the table. We'll print out, show that it knows its own location. And then we'll do a scan, and we'll only grab a couple of the fields. We won't grab all of them. Okay, so let's try it. Okay, so there we go. We got, showing the S3 location. We got our arrow table of reading just those 3 columns. And to show that there's, obviously more columns in that table, we can just go run. We can connect and just test out that the CLI and show that the full schema there. If you just run it, you're going to get help. Why is my computer so slow today? That's weird. Oh, it's probably recompiling it because I did a rebase. Oops. Yes, I said to recompile. Oh, okay. So we can see our basic options and normal stuff here. So it's going to do list, and we're going to do URI. REST catalog. What did I miss? List, options, parent. What argument did I miss here? It's dash. So. We're going to do list, and it's catalog. Well, the default's REST, so I don't need to do anything there. So URI. What did I do wrong? What did I miss? See, this is the problem with live demos. Wait, I know. Protocol scheme. Why are you doing this to me? Okay, I'll play with the figure it out. What did I do wrong here? Yeah, we'll deal with that later. Let's continue with the demo. Okay. So, having more fun to show off. No. Stop. All right. So one of the other things that I wanted to show off here is not only were we able to handle that with the SQL catalog, let's show off, I'm going to grab the REST catalog, and we're going to create a lovely table. We don't need to create the namespace because the namespace already exists. But let's create a table on the REST catalog. And then we can write the data, and I'm going to show there. Now, what we're doing here, if we look at this write table function, I am starting a new transaction on the table, and then I'm going to write the arrow table to that table. You could also do this, now append table is a convenience function. It's just creating a table reader under the hood. If you just use append, it accepts an arrow record reader, which is an interface, which means anything that can produce a stream of arrow record batches can be used for this append. And it'll respect the properties, it will parallelize internally, it will create it'll create a bunch of Parquet files and use the warehouse, and so on, appropriately. And then we will commit our transaction, and then to prove everything, we will do a scan to the arrow, and then create an arrow table from the scan, and let's check the number of rows. So, we'll run the example again. Okay, it's got recompiled, does the thing. Now it's actually appending the data table of data. And we see we got the right number of rows, everything's cool there. Now we can also see if we look at our local min.io, we can see if I refresh the page, yeah, I relog in, yep, because I restarted it. Shut up. So, hey, here's our taxi data set folder from creating the table. We have our metadata. We've got our snapshot and our metadata JSON. And we've got the actual Parquet file. Okay, so the data's all there, all nice and happy, but we can prove it out some things a bit more. ClickHouse supports reading Iceberg tables. And I'm running a ClickHouse server locally as Docker. So we can tell ClickHouse, select count star from Iceberg. Make sure I'm typing correctly. Iceberg min.io / warehouse taxi dataset. I typed something wrong. What did I type wrong? What? Ah, yes. See, there you go. Good catch, guys.
That was a trick question. You knew.
And there we go. It's got the right number of rows. And if I just do the actual, if I get rid of the count and just select star just to show that the data is actually there, and I can just like, I hate this keyboard. And to show that I didn't just like insert a whole bunch of nulls and nothingness. And there you go. So appended it, did my transaction, got my snapshot, and ClickHouse is able to read the snapshot and the data and metadata and show that I actually, did a correct write for Iceberg. And if you do more appends, you can use the metadata and the time travel and do that with ClickHouse if you like, and it works. Okay, so enough tempting the demo gods. So, helps if I bring the mic with me because I walk a lot. Okay, so the immediate next steps we're moving forward with. Wanting to append the data directly is not released yet, but also one of the benefits of doing it this way is the fact that, for example, I get to pick on Iceberg because Faco's here. Appends and inserts for Iceberg only currently accept an arrow table, which means you have to materialize all of the data to write it with Iceberg. You don't with Iceberg Go, because I accept the stream of record batches. It's not in the release yet, but soon. But also, I don't yet support doing schema updates or other schema manipulations. The transactions do not gracefully fail currently and will leave things that need to be cleaned up. So that needs to be, there's a lot more work to be done still. You can't write the deletes currently. You can replace files, but you can't write small deletes, fast deletes. And of course, more of the catalog support and integration testing. But the other thing I also love about Iceberg Go itself is that it gets more usage of Go in the ecosystem. Python is obviously the go-to for data ecosystem currently. But Python is also slow unless you're using compiled modules and dropping down to C and Rust, etc. Go has all the benefits of the concurrency and all the primitives and all the benefits I put earlier. But you don't often see it as much in the data ecosystem, or as much as I would love to. And a lot of that's because there isn't big support of like data frames and things like that in Go yet. There's no go-to data frame library. There's no polars for Go. And polars is just built on Apache Arrow anyways. So there's a lot of room to improve and to grow Go in the ecosystem, and one way of doing that is the Iceberg Go library to increase that parallelizability, concurrency, and just more usage of Go in the ecosystem, even if you're just writing servers or data applications that just need to interface with Iceberg and to read and write simple data. And ultimately, with the, recently it's been more pickup of contributors contributing to Iceberg Go, but for the most part, it's still pretty much just me and like one or two people, and a lot of help from Faco and Kevin that review my Go code, even though they don't really know Go. So please, if please contribute, help us get this to be a more full-fledged and more built out and structured and built out library, just because, well, that's the point of open source, isn't it? And so, obviously, thanks goes to the selection committee for all the fun nights of letting me do this talk. And finally, thank you guys for showing up and attending and at least looking like you're interested. So, thank you.
Thank you, Matt.
Do we have time for the Q&A?
We do. We have 15 minutes.
Woohoo!
So, all right.
So in the ClickHouse example you showed, you're pointing directly at the bucket. Mm-hmm. How does ClickHouse select the table version, like the initial metadata?
If I remember correctly right now, when you point it at the bucket like that, ClickHouse is picking the lexicographically highest version of the metadata.json file, because the standard, or at least the convention currently, is that the beginning of the metadata.json file is like a 4 or 5 digit like version number that's left padded with zeros, and so it will so doing it lexicographically will work because you prepend the UID with those numbers. ClickHouse recently did an article where they are supporting the Iceberg REST catalog spec, but I did not update my ClickHouse local Docker image soon enough and did not want to try to attempt that for this demo. So in theory, if with support of the Iceberg REST spec, it would just use the REST catalog like everything else. DuckDB makes me sad though, because they require the version hint.txt still.
Yeah, there's some guessing feature within DuckDB. I have a question on the whole ecosystem you were talking about.
Yeah.
Like with the Go implementation and the arrow streams and everything, like what are some interesting things that you think can be done? And I'm thinking towards like flight and like, you know, just something that's not like, you know, single machine moving data around because it's a stream now, right? It's not materialized. Like any interesting things that you can talk about?
I mean, so using Go in this does not enable anything that wasn't already enabled by any other non-Java thing, except for the fact that Iceberg doesn't support streams yet. But by supporting the stream of arrow data like that, it does enable things such as flight, or build a flight service and make a request to Dremio. And well, Dremio is a bad example since they actually support writing to Iceberg, but query InfluxDB or your own internal service and stream the result into Iceberg as a write. One of the other fun things that it actually could enable is ADBC support. You could have ADBC set up which is Arrow database connectivity, because when you run a query on ADBC, you get a stream of Arrow back. So you could connect ADBC to Postgres using the ADBC Postgres driver, and then make a query, and then write it to an Iceberg table, because that can accept the stream, and so you have that really easy scenario of just ingesting into an Iceberg table via ADBC source. That could be DuckDB. It means that DuckDB could actually do an Iceberg write technically, because DuckDB implements the ADBC interface. You can use DuckDB as an ADBC driver.
Yep. You
could then query DuckDB, stream it into Iceberg Go write, and then do stuff with it if you want to. Right. Or any other system that does not yet support Iceberg writes or reads can be utilized with this because of the arrow streams. Yeah. That's the main reason why I'm using the arrow streams, is that interoperability aspect, maintaining the column-oriented nature of the data, because you're reading from Parquet files.
Right.
So keeping the data column-oriented as long as possible. It makes the filtering more efficient. It makes the interoperability with other systems and other libraries. You could stream a query from Iceberg Go and pass it to ADBC ingest. You could stream into a Postgres table, for example, from an Iceberg table using Iceberg Go and ADBC, because it works in both directions.
Right.
Common standard.
And the streaming means that you get to avoid materializing stuff.
Cool. Thanks. It's really a good talk. I have one question about like the streaming. One thing that we run into with Java is more about like when you start streaming data, you, for example, don't know, for example, which partitions there are. In Spark, actually, Java, I should say, there are two ways of doing it. First, that you sort the data, but yeah, that's not possible in streaming. So if you start writing this data, would you like keep all the file handles of the different partitions open then, or like how would you do that?
So the way I did it for it, because one of the nice things about the way Iceberg works is that the actual paths don't really matter in most cases. And so by utilizing certain metadata properties and just enabling options in general, basically just say how many batches backwards do you want me to keep a look at to do the bin packing. And for partitioning setup, you know, you may end up with a non-optimal write of where data got ultimately written with the, you know, your cloud object store prefixes. But Iceberg doesn't care as a format. Like you might care because of the way cloud storage does rate limiting, but as long as you like filter the data appropriately, fair warning, I have not yet implemented partitioned writes with streams yet.
Okay. Yeah, that was my question. Yeah.
To be fair, yeah. That is an important piece here of, I have not implemented the partitioned writes yet, so half of what I'm saying may end up changing when I try to actually do that. I only have unpartitioned write streams currently.
Cool.
But at least in theory, the way I think of it is the fact that you may end up with non-optimal location like paths when you're writing out the stream like that if you don't tell it to look far enough back. But in theory, you just need to decide how big do you let a file get before you cut it off and start writing the next file in that partition. It's just a bin packing problem.
Yeah, I think that's the easy part. Like if you have very few partitions, then you have like just a few file handles open, probably with like pretty big buffers, just to make it efficient.
Yeah, but if you have a lot of partitions,
Yeah.
you're absolutely correct.
That's going to be painful.
You need to decide how many do you allow it to keep open, or do you let it do smaller files? And yeah, a lot that needs to be thought about when I get to that, or when someone helps me get to that. But you are absolutely correct.
Yeah, I think it's pretty reasonable. Like you're saying, like Iceberg is pretty flexible in that sense. So maybe just closing down the file if you have not seen any particular records for that specific partition, and just open up a new file. I think that would be pretty reasonable. Yeah.
Yeah. And also, Parquet is flexible enough because of the way row groups work that if you don't mind some non-optimal way of the Parquet file, in theory, you could just write another row group to the same Parquet file and then just update the metadata and write the new metadata footer. Not optimal in any way, but would allow you to not have a ton of small files while also not keeping the file handles open.
And also, like on top of that, probably with streaming, you need to have some pretty aggressive compaction anyway. So
yeah, you're gonna have to run with the streaming thing. You're gonna need to run the compaction afterwards at some point.
cool.
What is your preferred way to accept or discuss the contributions? Is it Slack or file a GitHub issue, mailing list? What do you
The easiest route is either using GitHub issues or the Iceberg Slack. There's a Go channel. When the amount of contributors gets large enough, I'll probably try to organize a like biweekly community sync thing like Iceberg Rust has done. So far I haven't, just because there aren't enough consistent contributors where it would, you know, I don't want to be just me sitting in a Zoom call shouting at the void. So when there's more consistent like number of contributors, I'll probably try to work with the Iceberg PMC and organize something like that at that point. But for now, either issues on the Iceberg Go repo, or I'm always in the Iceberg Slack Go channel.
That was good.
Thank you. That was actually going to be my question, so thank you so much for asking it. Great. I think that's all the questions we're going to take. Thank you so much for the presentation, Matt.
Thank you, everybody. Thank you.